I want to find the upper and lower bounds for this number, which has been measured to two significant figures. So 760 to two significant figures means that my cutoff is here, so it's been measured to the nearest 10. If I get that 10 and half it, I get 5. So to calculate the upper bound, I add 5 onto the 760 and get 765, and for the lower bound, I subtract 5 from the 760 and get 755. So this is my upper bound and this is my lower bound. I want to do the same thing for this number, which is measured to two decimal places. Now the first decimal place is this one here, the tenths, and the second decimal place is this one here, the hundredths. So this has been measured to the nearest hundredth, which is 0.01. If I divide that by 2, I get 0.005. So to find the upper bound, I add 0.005 onto this number and get 15.675. And to find the lower bound, I subtract it to get 15.665. So this is the upper bound and this is the lower bound. Here are two for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now we're going to increase the level of difficulty a little bit. In this question, we're going to have to work out some bounds and then use them to do a calculation. So we need to work out which bounds to actually use. You'll see what I mean as I go through it. So Sue drives her car a distance of 320 miles, correct to two significant figures. So I'm going to find the upper and lower bounds for this first. So 320 correct to two significant figures means that this number is to the nearest 10. Half of that is 5, so I'm going to add on 5 and subtract 5 to get the upper and lower bounds. That's 325 and 315. Now I'm told her car uses 49 litres of petrol, correct to the nearest litre. So 1 litre divided by 2 is half a litre. So I'm going to add on a half and take away a half to get the upper and lower bounds for this number. So I get 49.5 and 48.5. Now what I want to work out is in miles per litre, so that means I've got to divide the miles by the litres, and I need to find the maximum value. So for the maximum value, I want the largest possible miles, so that's the upper bound of the miles, and I want to divide that by the lowest possible amount of petrol, so that's the lower bound for the petrol. So that gives me 325 divided by 48.5. Using a calculator and rounding to one decimal place, I get the answer 6.7 miles per litre. Here's a question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Just out of interest, 50 crates is right on the limit of the braking strain, so you might also write the answer 49 crates, and this is also an acceptable answer. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. To calculate this, you need to work out your bounds first of all. Then, to be completely safe, you want to pretend that the boxes are as heavy as they can be, so you take the maximum, the upper bounds for the boxes. There's 3 of these, that gives me this, and 7 of these, that gives me this, and I then add them together. Now, again, for safety's sake, we want to pretend that the safe load is the lowest possible value it can be. So we need to see whether this is more or less than this number here. Because it's more than it, the lift cannot safely carry the boxes. Now this is a very particular type of question. You can spot this kind of question by looking out for these words here. We're looking for an appropriate degree of accuracy. This means that you've got to do something very specific when you round off these numbers. It's really tempting to say, well, the lower bound is this, and the upper bound is this, so I'm just going to go for one decimal place and say it's 1.7. But because it says this, you've actually got to do a bit more work. You need to find the most accurate answer where both the lower and upper bounds will agree. I always start from the left. If I look at the first digit of each number and say that I'm going to cut the numbers off here, they're both 1, and with a 7 coming after both of them, they would both round to 2. But we can probably be more accurate than that. If I look at the next digit along, this is 1.7, and so is this. Because of the 1 and the 2 here, they would both stay as 1.7, so they both match. But I can probably be more accurate than that. If I go one more digit along and make my cutoff point here, I can see this is 1.71, but with the 6 here, that would be 1.72, and this is 1.72 as well, so they both match at this point. If I go one more digit along, I can see that this number here is 1.717 when I round it off, and this one is 1.725. So this is the point where they're different. So what I need to do is go back one place. And that makes my cutoff point here because both of these numbers will round to 1.72. So this is my answer. To finish, I need to explain why this answer is appropriate, and I always write the same thing. The upper and lower bounds both agree to this number of figures. Here's one of those for you to try now. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Now here's a slightly more difficult question for you. In this one, you've got to work out your upper and lower bound for m before considering the suitable degree of accuracy. Press pause and have a go. When you're ready, press play. Here's the answer. To get this, I calculated the lower bound for m and the upper bound for m, and they both round to 0.229.